spend some time going over some of these problems on your study guide before you take your test. So a couple problems I want to go over. The first one I want to talk about, let's look at number 5. Okay? It says assume the mean of a data set is 22 and the standard deviation is 5. Create a bell curve. Okay, so I'm going to open up a bell curve. What always goes in the middle of my bell curve? The mean. What's my mean in this problem? 22. Okay? How many tick marks do I go to the right? I go 3 tick marks to the right. How many do I go to the left? 3 to the left. So, all right, I'm going to increase by my standard deviation, which is 5. So 27, 32, 37. Go in reverse, subtract. You get 17, 12, and 7. So 5A says how many of these score falls within 1 standard deviation of the mean? Okay. What is the value of 1 standard deviation above the mean? That's right here. Well, that's 27. What is the value of 1 standard deviation below the mean? That's right here. That's 17. So, between 17 and 27. So how many units are between 17 and 27? 10. If you wanted to also talk about the percent, some of you remembered the percent between these two is 68%. You could also say that as well. Okay. Letter B. What value is 3 standard deviations below the mean? So here's my mean. 1, 2, 3. That's 7. Hopefully everybody is okay with that one. Let's now look at another one. Let's talk about this problem. I'm not going to do all of it, but I am going to do some of it. So I want to do letter D, okay? But we'll also talk about C here real quick too. It says find the mean and standard deviation of the data. So I got to find the mean first and the standard deviation. So I'm going to open up my calculator. So let me pause real quick here. Alright, so if I pull my calculator up, if I push stat, push edit, I'm going to enter in my data. So 100, enter, 82, enter, 97, enter, 75, enter, 85, enter. Press stat, go over to calc, hit enter. Now my screen here looks a little bit different than your screen, but we still go down to calculate and hit enter. So you should get x bar equals 87.8 and sigma equals 9.4. Okay? So it says for part C, Alice's test score was a 97. How many standard deviations is her score from the mean? When it says how many standard deviations something's from the mean, what should you calculate? A z-score. So I'm going to use my formula for z-score. My formula for z-score is on my whiteboard, so if you don't remember it, it's right there for you to reference. So I do 97 minus 87.8 divided by 9.4. Okay, so I'm going to clear this out if I can type. All right, 97 minus 87.8, enter, divide by 9.4, enter, z equals 0.978, which basically rounds to 1 standard deviation above. Okay. Let's now minimize this here. All right. Now let's look at Martin's score here. Let me put this back up. Okay. So it says Martin scored 0.89 standard deviations below the mean. So since this is below the mean, 0.89 should really be negative 0.89. Okay? What is this test score to the nearest whole number? So when I'm looking for his test score, that means I'm looking for x. 0.89 standard deviations below the mean, this calculates his z-score. So it said his z-score was negative 0.89. So I have negative 0.89.
Hi, if you are in the building, you have a phone call in the front office.
So I have negative 0.89 equals x minus my mean, which is 87.8, divided by my standard deviation, which is 9.4. So now I have to solve for x. So how do I solve this equation to get x by itself? What's the first thing that I do? Get rid of fractions. Multiply both sides by 9.4.
So now please come to the...
Okay, so 9.4 times negative 0.89. I come over here, you get negative 8.4 equals x minus 87.8. Okay, how do I get x by itself now? You add 87.8. X equals 79.4. It says round to the nearest whole number. So how did Martin do on his test? Martin scored a 79% on this test. Let's look at number 7. Okay. Barbara took 2 tests. In English, she received a score of 38. The mean of that was 35. And her standard deviation was 0.5. On physics, she received a score of 52. The mean was 49, and standard deviation is 0.8. All right, what's the only thing I know what to do with these 3 variables? Calculate a z-score. 38 minus 35 divided by 0.5. Over here I have 52 minus 49 divided by 0.8. If you calculate, you get z equals 6 over here. Over here, you get z equals 3.8. Okay? Which one did she do better on? So this is where we have to look at a bell curve. Okay? On a bell curve, is it better to be closer to your mean or further away from your mean? It's better to be really closer to your mean. Because remember we talked about that if we're over here in the wings, we have a less likelihood of something occurring. So that means the further away something is from the mean, the less likely it's going to occur. So out of your 2 z-scores, which one is closer to the mean? Well, 3.8 is obviously closer than 6, so she did better on physics. Okay, let's look at number 8. The table shows scores of an algebra test for 4 different classes. It also shows the z-score for 1 student in the class. Who had the highest score on the test? All right, well, we see the word z-score, so we know we have to use our formula. So let's plug in what I know. Z for Bob is 1.3 equals x minus the mean, 82, divided by the standard deviation, 10. Solve this for x. (13 plus 82). X equals 95. So Bob got a 95 on the test. All right, now let's try Morris. 1.1 is the z-score. X is the test score I'm looking for. He got an 88 on the mean, and the standard deviation is 9. Multiply both sides by 9. 1.1 times 9. You get 9.9 equals x minus 88. Add 88 to both sides. Morris got a 97.9. Now let's try Kathy. Kathy got a 1.4 z-score. We're looking for her x. Her mean was 84. Her standard deviation was 11. Multiply by 11. You get 15.4 equals x minus 84. You add 84. X is 99.4. Last one, let's try Robin. Robin got a 1.8. We're looking for x. Her mean was 79. We divide by the standard deviation, which is 6. How do I get x by itself? Get rid of fractions. Multiply both sides by 6. 1.8 times 6. You get 10.8. Add 79 to both sides. You get 89.8. Who did the best in who scored the best? Kathy. Okay. The data shows a mean of 65.4 and a standard deviation of 26.7. How many of these data points have a z-score greater than negative 0.4? So I have to calculate each of these values z-scores and see which one's bigger than negative 0.4. So I have to do 32 minus 65.4 divided by 26.7. I have to do 36 minus 65.4 divided by 26.7. I have to do 41 minus 65.4 divided by 26.7. I have to do 43 minus 65.4 divided by 26.7. I have to do 47 minus 65.4 divided by 26.7. All right, so I got to calculate 5 z-scores, so let's try. 32 minus 65.4 divided by 26.7. You get z equals negative 1.3. Is that less than negative 0.4? No. Try the next one. You get negative 1.1. Is negative 1.1 less than negative 0.4? I'm sorry, not less than, greater than. No. Now try 41. 41 minus 65.4 divided by 26.7. You get negative 0.9. Is that greater than negative 0.4? No. Now try 43. 43 minus 65.4 divided by 26.7. Negative 0.8. Is that greater than negative 0.4? No. Now try 47. You get negative 0.7. Is that greater than negative 0.4? No. So none of them work. So we did all that work for nothing. None. Number 10, you have to calculate each of these test scores for the z-scores. You have to determine who got less than negative 2. So what happens if somebody gets negative 2? Does that count? Well, is negative 2 less than negative 2? No. They have to score less than a negative 2. So if somebody scores a negative 2 on their z-score, they are not qualified to do a retake. Okay? I hope everybody is okay. If you have any additional questions, make sure you ask, maybe ask your partner, see if you can figure this out together before you take your test. Remember to take your time, show your work when necessary, and do not round to a whole number unless the problem tells you. Good luck, everybody.